Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, episode 27. We're going to start looking at quaternions today, and we're going to be looking at them for quite a few episodes. Today we're just going to be doing a few things with them. We're going to look at their general notation, their relationship to complex numbers, using them with an axis angle pair, and performing negation on them. So all it is it's another way to express orientation, but we're going to use four numbers this time, so it's more than Euler angles, but less than matrices. It's going to contain a scalar component, W, plus a 3D vector, represented by V, or individual components of V, X, Y, and Z. Note we're going to have no difference between row and column notation. So you'll have W, V here, or W, and then X, Y, Z. How they relate to complex numbers is it basically extends the complex number system, or if you recall what that is, it's generally I squared equals -1. But we're going to have three different components of that, where I squared is equal to J squared is equal to K squared, and all of those are equal to -1. Additionally, a few other things are true of this. Ij is equal to K, and Ji is equal to -K. Jk is equal to I, K and J is equal to -I, and then Ki is equal to J, and Ik is equal to -J, and that's what that should be saying. -J. And then W of x, y, z here is equal to W plus xi plus yj plus zk. In terms of axis angle pairs, we have an axis angle pair defined by this set of theta n, where the angular displacement is of theta radians about any particular axis specified by n. And the four values of the quaternion can be represented by q here, where it's cosine of theta over 2 times sine theta over 2 n, or in the expanded form we're going to have cosine, sine, and this will have n of x, n of y, n of z. Finally, getting here to negation. Negation is performed easily. We're going to have four values for quaternion, and we'll just have the negative value here put in front, and that can basically get applied to each individual piece within it, so it gets applied to the W as well as the individual components X, Y, and Z, or in the shorthand format, the W and the V. Finally, Q and -Q represent the same angular displacement in quaternion negation, and adding 360 degrees to theta doesn't change the angular displacement but negates all the components of Q. So mathematically speaking, they don't count it, but they will count it here. So that's it for this episode. If you like what you saw, go ahead and subscribe and give a like, share on social media if you will, and go to ProgrammingTIL.com and sign up for my newsletter. Have a great one. Thanks.